Part A, prove that for all positive values of A and B, 4A over B plus B over A is greater than or equal to 4. So this is the result that I'm trying to prove, but I'm not entirely sure where my starting position for this is going to be. So this is one of those reverse engineering type questions I'm going to do. So I'm going to do some rough working out with the answer, and that will hopefully give me a clue as to how to solve this problem. So I'm going to work backwards from the answer. So starting with the 4A over B plus B over A is greater than or equal to 4. What could I do here? Well, I could get a common denominator to bring these two terms together. So that would mean that I'd times the first term by A, and I'd times the second term by B, which would allow me then to say that 4A squared plus B squared over AB is greater than or equal to 4. I'm then going to multiply both sides by AB. Now I do need to be a little bit careful at this stage because this is an inequality and I might need to flip the sign, but we did know that A and B are both positive, so therefore I have actually multiplied both sides by a positive number there, so I don't need to flip the direction, thankfully. Next, what I'm going to do is I'm going to subtract that 4AB from both sides, just so this equals 0. And now I notice that on the left I can factorise this. And I notice it's going to be 2A minus B all squared, because I know that 2A squared is the 4A squared. The 2A times the minus B is minus 2AB, and we double that to get this. And I know that the minus B squared is the B squared there. Now, after all this rough working out, I have got to something that I know is definitely true. Because what I've got here is a square number is greater than 0, greater than or equal to 0. And I know that's definitely true. Square numbers are always greater than or equal to 0. So this is my starting point for my final answer. I know that 2A minus B all squared is greater than or equal to 0. That's my starting point for this question. That's my known fact that I'm going to work from to get to the 4A over B plus B over A is greater than or equal to 4. I'll expand the brackets. I'm going to add the 4AB to both sides. And then I'm going to divide both sides by AB. And because A and B are both positive, I don't need to worry about flipping the direction of the sign. And this now allows me to split this up into two fractions . And cancel the A here and here, cancel the B here and here. And this was the result I needed to prove. Now I have done that, I'm going to cross my rough working out, because this is my final answer. So that's part A done. Part B says to prove by counterexample that this is not true for all values of A and B. So the statement I just wrote down was true for positive values of A and B. Well, what about if one was positive and 1 was negative. So let's just find some values that might work nicely. So if A was, let's say, I don't know, 6, and B is minus 12. The reason why I'm selecting 6 and minus 12 is I know they're going to divide nicely by each other. So substituting those in, then I'd get 4 times 6 over minus 12 plus minus 12 over 6. That's 24. 24 divided by minus 12 is minus 2. Minus 12 divided by 6 is minus 2. And minus 2 plus minus 2 is minus 4, which is less than 4, not greater than. So this is a counterexample to show that this is not true for all values of A and B. It's only true for positive values of A and B, or at least it's certainly not true for all values of A and B. I chose 6 and minus 12. You can choose any numbers as long as you get the result where 4A over B plus B over A is not greater than or equal to 4.